Alright, let's go through the solution to problem number 3. So in this case we have a car wash. We're given the price of the different washes. So $5 for cars, $9.50 for vans, and $3.75 for motorcycles. We're told a relationship between the number of vans and the number of cars, so 4 times fewer vans than cars. We're told the number of motorcycles washed, and we're told the total amount of money they've raised. So we're also told that the governing board is going to give money based on how many vehicles are washed. Okay, so we're given this graph that's supposed to tell us that. And the question is, how much money is the school going to donate? So in order to figure that out from the graph, we're going to need the number of vehicles washed in total. Okay, and that we can get from the first paragraph. So let's start with just looking at the first paragraph. We're going to use it to find the number of, we want the number of vehicles that are washed. So why don't we set up our variables? So we don't know the number of cars, so let's C equal the number of cars, V equal to the number of vans, and M equals to the number of motorcycles. So M doesn't really need to be a variable at all because we already know what it is, but let's do this for completeness. So I know that the number of vehicles washed in total is going to be C plus V plus M. Okay. So from here, we need to do our systems of equations now. So we need to solve for our C and our V. So let's first set up the equation using the cost. So I know that for every car washed, I get $5, okay? So if 3 cars were washed, I would get $15. If 10 cars were washed, I'd get $50. So I know the amount of money from the cars is going to be $5C. Similarly, the amount of money from the vans is going to be 9.5V. And finally, the amount of money from the motorcycles is going to be 3.75 times M. And I know that that altogether needs to be equal to the amount of money that they raised in total. So that's going to be $531.50. All right, the other equation that we can come up with is, well, the students washed 4 times fewer vans than cars. So I know that the number of cars needs to be 4 times the number of vans. So if I were to set that up in an equation, I would say that the number of cars is equal to 4 times the number of vans. Okay. Another equivalent way to write this would be V is equal to C over 4. 4 times fewer vans than cars. Okay, so in order to make sure this makes sense, I would recommend plugging in a number. So for example, if I know that they washed 8 cars, then they'd have to wash 2 vans. Right, so does that work in our equation? If we plugged in V as 2, would that give us 8? Well, yes. Okay, so this equation seems to work. So now we've got 2 equations. We have 2 unknowns now because we know M, so we'll plug that in. We will plug that in the next step. So now why don't we replace, we can do substitution, so we can replace C in the first equation with C in our second equation. So let's do that. We've got 5C, so C is the same as 4V plus 9.5V plus 3.75 times m, which is 8, we already know, gives us $531.50. So 375 times 8 is 30. 4 times 5 is 20, plus 9.5 would be 29.5 V's, plus 30 is equal to 531.50. Let's subtract 30 from both sides. You got 29.5 V is equal to 501.50. Divide that by 29.5. You get that V is equal to 17. Great, so we know the number of vans. Let's use that to find the number of cars. It's probably easiest to use the second equation. C is equal to 4V. So I know that C is equal to 4 times 17, which is going to be 68. So now I know, okay, I still want the total number of vehicles washed. So my cars, my vans, and my motorcycles. How many cars do I have? I've got 68 cars. How many vans do I have? Well, I have 17. And how many motorcycles do I have? Well, I have 8. So in total, this gives me 93 vehicles. So now I need to look at my graph, and my graph should tell me, okay, if I've washed 93 vehicles, how much will the school donate? Well, 93, again, that would be the X value. Well, that's not on this graph, right? So we need to find the equation of this graph. We know that it goes to the point 10.9. It's definitely not linear. It's not exponential because it goes through the origin at 0, 0, right? It goes through the origin. So in this case, we actually have an exponential, not an exponential, a quadratic equation. So we have something that's of the form y equals ax squared. So we can use our point, so that's 10 and 0.9, and we can plug that into this equation. So 0.9 is equal to a times 10 squared. 0.9 is 100a. So if we divide by 100, we get that a is 0.009. So the equation that we're dealing with is 0.009 x squared. Then finally, to get the amount of money that they're going to give, well, we know how many vehicles, that's x, so let's plug in 93 for x. Y is equal to 0.009 93 squared. If you plug that into your calculator, you get that y is 77.84. So the school donates 77.84.